Matovu Steveniga, a physics teacher at St. Goret SS Manyogaseka, is a mixed girls and boys government-aided high school in Uganda, the third largest economy in East Africa. The school has boarding and day section, and I teach senior 5 class, of which it is only in boarding section. My class is embraced with 45 students, whom I do teach in whole group settings according to new curriculum. They are boys and girls in groups of 5 5, meaning those are 7 7. If you take 5 times 9, meaning those are 9 groups with an average age of 15.5 years. Academic characteristics of my students: most of my learners are above the average, because all learners are supposed to be in boarding section if you enter S5. Since the school has boarding section, some are average, and this has enabled me to give enough time to them and also get time for their revision, supervision, and guidance. I'm handling modern and atomic physics, a well-known topic in physics that deals especially on the behavior of atomic nucleus, quantum theory, and its properties. Disabilities. In this class of 45 students, not all learners are fine. Some of my students have disabilities that bring hurdles in their learning. One of the students have an eye impairment, a long-sightedness. In this case, he cannot see when he is seated near from the board. Other 2 students also have a problem of not hearing well, therefore they need a teacher to increase on the volume or speak louder in most cases when they are far from the teacher. Communication skills of my students: most students in general are assertive. In this case, they have confidence to express their views. Since it is a mixed school, boys and girls often are happy, positive, cheerful, sociable, and to generalize the matter, their communication in English is generally good. The core standards that will be addressed in this unit include the ability of students to analyze the quantum theory of different particles, the concept of photoelectric effect, the common properties of cathode and X-rays, and the spectrum, and discuss both Bohr and Rutherford model of hydrogen atom. General unit objectives: by the end of this unit, learners should be able to explain how cathode rays and positive rays are produced in discharge tubes and at low pressures. Use the concept of photoelectric effect to introduce quantum theory. Explain emission absorption of spectra X-rays. Determine the stability of nuclei. Discuss the different models of an atom. Calculate the decay rates for various unstable isotopes. Explain the Thomson's tube scattering experiment. Explain the Milkman's oil drop experiment, and explain the energy band. Specific objectives: by the end of this unit, the learner should be able to discuss the behavior of cathode rays and positive rays and their properties, describe the production of both cathode rays and X-rays, determine the charge per unit mass of an electron, analyze photoelectricity and Einstein's photo theory, identify the practical applications of spectra X-rays and their properties, analyze the de Broglie formula, describe nuclear energy, determine half-time and its application in radioatoms, solve the decay rate of an atom, describe the Bohr and Rutherford's model of hydrogen atom, explain the Milkman's airdrop experiment, describe the working principle of Bridge mass spectrometer, explain the operator of Thomson's tube experiment. Formative assessment. Formative assessment refers to the process where a teacher assesses learners during the course of the learning. This can be done at the beginning or amidst through different activities like giving them tests, giving them examinations. Among the formative assessment I'm to use is a 3-minute paper. In this case, 3-minute papers are usually done at the end of the lesson, whereby each group brings the marks after doing that paper and are tasked to answer a brief question in writing. After the task, these papers are then collected by me for analysis so that he or she gets strengths and weaknesses of the learners. Of course, we correct the weaknesses and we give positive feedback to those groups who have performed well. Here shows the table of specification. Here is the table of specification. Here there is week, the objectives, time spent on a topic, percentage of class time on a topic, number of test items, lower level, higher level. Week 1, we discuss the behavior of cathode rays and positive rays and their properties. Time spent on this topic will be 160 minutes. And percentage of class time on each topic is 8.8%. Number of test items will be 2.112, and I give them 2 essay questions. To describe the production of both cathode rays, determine the change per unit mass of an electron, the mass defect of a radioactive atom. In production of cathode and the X-rays description, the time will be 8 minutes, that is 4.4% to 1.056. There will be 2 essay questions. Determine the charge per unit mass of an electron and the mass defect of a radioactive atom. This one will take 60 minutes. That is 3.7%, 0.88 tests, and 2 short questions. Determine the charge per unit mass of an electron and the mass defect. In my week 2, we shall begin charge per unit mass of an electron, mass defect of radioactive, and that will take 120 minutes. Under the same, we shall identify the practical applications to spectral X-rays and their properties, and it will take 60 minutes. Briefly, you can see my table each week. That is week 3, week 4, week 5, week 6, and so on. And under my table specification, I divided my time following my school timetable, whereby in every week I'm allocated 5 hours of teaching. When converted to minutes, it sums to 300 minutes per week. According to my schedule, I teach double lesson on Wednesday in the morning from 7:20 to 8:40, on Thursday in the afternoon from 2 p.m. to 3:20 p.m. I'm allocated another double lesson, and during the prep time on Thursday, which starts at 8 p.m. I do teach for 1 hour, whereby I use the 40 minutes to teach my students, and in the remaining 20 minutes I assign them with discussion questions, where each group is mandatory to present its findings for marking. On Friday morning, I'm allocated another double, which starts from 7:20 a.m. to 8:40 a.m. Following the schedule and my workload, it's very simple for me to cover up the content in time and have the extra 10 minutes for my students to do my assignments progressively. Here is the summit, whereby this is a physics end of term 2 exam, St. Great SS Manyongasika, and it has 2.5 hours. They answer only 5 questions. My scoring rubric: a student will get 6 if the approach chosen is clearly shown, clear written, and all elements are valid. 5 if valid approach with minor errors that don't disrupt understanding. 4 with valid approach with multiple errors that impede understanding. 3 invalid approach that demonstrates little understanding of the problem. 2 or 1 little or no understanding of how to approach the problem. According to me, I don't give a student 0 marks because really it is not fair for a student to come and attend your class and to give him 0 marks. And according to new curriculum of Uganda, it is very bad to give a student a 0. And here is my scoring rubric. The table shows my the table shows my scoring rubric. Above is criteria and rating, strategic approach, physics concepts, mathematical concepts, and answer. As you can see, lastly, ensuring reliability and validity.